Okay, we're going to be talking about integration using substitution. But before we do that, we're going to recall the chain rule. All right, now the chain rule was something really important when we were talking about derivatives. The chain rule enables us to take derivatives of composite functions when you have a function composed of another. In this case, f composed of g of x. So let's recap on what that means. If you are taking the derivative of, suppose, f of g of x, you take the derivative first of the outside, that's f prime, you leave the inside alone, g of x, and then you multiply by the derivative of the inside, and that's how you get this g prime on the outside. Okay, so that's the chain rule. Now think about this. What if you wanted to take the antiderivative of that? Well, if you want to take the antiderivative of that, you need a particular method to go about doing that. And that's where this concept of substitution comes in. Substitution allows us to take the antiderivative of a composite function. So let's go ahead and take a look. This right here that I'm going to highlight is the result of the chain rule. So we take the antiderivative, all right, and we're going to obtain something so that we can get the antiderivative of this. We're going to do a little process called substitution. And that is to say that if you have g of x, you can call it u. Okay, so g of x is u. And if you have g prime of x dx, so let me go ahead and highlight that differently. All right, so here's g of x. All right, and that's u. Well, then if you have g prime of x dx, so g prime of x dx, all right, that's going to be what you call du. So this is your du, and this right here is your g of x. Okay, so you kind of separate those things. Well, maybe not necessarily separate them, but you kind of group them, and you'll see when we get to the examples what I mean by grouping. But you do this, then you can do integration with the techniques that you've already known how to do when you're evaluating derivatives, so, or integrals, I should say. So we're going to talk about this first in the case of indefinite integrals, and then in another video we'll talk about definite integrals and how you go about doing that. But those, once you figure this part out, the definite integrals are actually really easy, and they make integration a lot of fun, if you ask me, because it's nice to be able to take something that looks so complex and simplify it. So what we're going to have to do when we do substitution is understand that this is one part derivative and one part integration. So what we're going to do, we're given the following integral with a given substitution. They right off the bat tell us that u will be 9x squared. All right, that is this inside function here. Okay, so that's our u. All right, so what we're going to do here is we're going to say, well, if u is 9x squared, then what is the derivative of u? Du. What is the derivative? Well, the derivative of 9x squared is 18x, and we're going to say dx. So what happens here is that you need to have in your original function 18x in order for this to work. Well, we don't see it, and it's not there. There's a mathematician that I follow, James Tanton. He's actually an awesome mathematician, and if you ever get a chance, go watch his videos, goodaymath.com. But he says, if you want something in life, you make it happen, okay? But then you deal with the consequences. So let's say we want to have an 18x in front. Well, I notice I've already got an x. What am I missing? An 18. I want an 18, I've got an 18, but then I have to deal with the consequence of that. I can't multiply by just 18. I have to multiply by 18 so that it is equivalent to 1. So if I put an 18 inside of there, I've got to write outside 1 over 18, because what is 18 times 1 over 18? 1. Okay? I can only multiply these things by 1. All right? So that's the necessity for putting in the 18, but then writing on the outside the 1 over 18. All right? So now that I've got that there, what I'm going to do is I'm going to put a ring around what it is that I know and that I see. All right? So if you see here, you have 18x dx. Well, I'm going to ring that. Okay, and this is what I mean by ring. I put a circle. I mean, it's not a circle, but you get it. That represents my du. And this right here, the 9x squared, represents my u. And so now what I do is I rewrite this integral knowing what I know now. And that is to say that I have a 1 out of 18 on the outside. The integral here will be now of cosine of u du, because I have made those substitutions. And now this is something that's really very elementary. If you know the integral of cosine, okay, you know that it's just sine. So you're going to say 1 over 18 sine of u plus c. Now the only thing left to do here is to back substitute your u. So your u is going to come back into play, and you're going to say 1 over 18 sine, in this case, of 9x squared plus your constant of integration, c. So you have something that looks like that as your answer. Okay, and it makes it really nice here. Okay, and that's pretty much all there is to it. Now we're going to go over a couple of more examples. I'm going to give you u. I'm going to tell you what the substitution is, but then in another video we're going to have to decipher and figure out what u is on our own. So let's go ahead and continue with these types. So here is number 2, and in number 2 they tell us that u equals 5x minus 2. We're looking at the integral of 15 times 5x minus 2 to the negative 6th dx. So du is just going to be 5 dx. All right, well, I don't see a 5 there, but I have to think about this in a different way. And so what I'm going to do is say, well, 15 can be broken up as 5 times 3, right? So I'm going to consider that when I work on this. So I'm going to write here 3 times 5 in this case times 5x minus 2 to the negative 6th power dx. And so I've got that right there. Now what I'm going to do is I'm going to circle my du and my u. So 5 dx is right there. That's my du. And this right here on the inside is my u. And now I'm ready to integrate. So I've got my 3 on the outside, and when I rewrite this, it's going to be u to the negative 6th power du. And now I'm ready. So 3u, negative 6 plus 1 is negative 5, divided by negative 5 plus c. And so I'm going to clean this up just a little bit to say negative 3/5 of u to the minus 5 plus c. And now I'm ready to back substitute negative 3/5. And in this case, u was 5x minus 2 to the negative 5 plus c. And I have my integral. So it's really nice. If you see here, we're just kind of undoing what happened in the chain rule when we took the derivative. But let's take a look at another one, number 3. Now this one is slightly more challenging, but there's nothing to it. We're going to get through this together. All right, so let's take a look at this one. This one says u equals 1 minus s to the 4th power. So we shall take du to be negative 4s to the 3rd power ds. Okay, now I notice here that I don't have a negative 4, but I can make it happen. I can make it happen. And so what I'm going to do is I'm going to say, well, 28 can be divided by negative 4, right? Negative 7. So this right here will actually be a negative 7 times a negative 4. All right, and that's how we're going to go about doing this one. So let me go ahead and maybe start it over here on this side. And that's to say negative 7 times negative 4 s cubed divided by the square root of 1 minus s to the 4th, and ds. We can't forget the ds, differential. So I think now I'm ready to ring everything that I need to ring, and that is to say that this right here, negative 4s cubed ds, represents my du, and this right here represents my u. And so I'm going to clean it up just a little bit more to say that I have a negative 7 on the outside, and it's the integral of du over u to the 1/2. and clean it up just a little bit more again to say that it is u to the negative 1/2 du. And now that I've got that in place, I am ready to integrate. And that's exactly what I'm going to do. So I'm going to write this out traditionally in the sense that I'm going to add 1, but in this case I'm going to add 2 over 2. Negative 1/2 plus 2 over 2 is 1 over 2, so I'm also going to divide by 1/2. I put my constant of integration there. But this right here, negative 7 divided by half, becomes actually negative 14, right? And then I have u to the 1/2 positive plus c. And now I'm ready to back substitute what I need to back substitute. And that is to say that negative 14 will now get multiplied by 1 minus s to the 4th power. All of that raised to the 1/2 power, or you might write it as a square root. And I guess I could go ahead and do that. I've got enough space here. Negative 14 times the square root of 1 minus s to the 4th, all plus the integration, the constant of integration c. So that right there is a set of 3 examples of where we kind of take the antiderivative of what happened in the chain rule. All right. You have to be very clever about how you pick your u. In these examples, u was given to you. In the next video that's coming up after this one, you have to figure out what u is. So use your own intuition there. All right. As always, I hope this video was helpful. And as always, remember, like and subscribe.